Hello, everybody, and welcome to this first session of Coffee Break with Eddyfi. My name is Frederic Reverdy, and today we're going to talk about Weld overlay for nozzle and node component. This is a new feature that has appeared in Capture 3.4. So if you already have a Gecko or a Mantis, please update your Gecko or your Mantis to benefit from it. And here is my email address in case you have any questions about this. All right, so let's go back in time a little bit with Capture 1.6. Man, I'm getting old. At the time, we developed an application to help operators inspect nozzle and node component. The idea behind that development was to allow the definition of nozzles directly on equipment, so as the Gecko at the time, the definition of trajectories on the main pipe or on the nozzle itself, the ability to use 3-axis encoded scanners, because the Gecko and the Mantis both have 3-axis input, and to be able to display in real time a cross-section of the nozzle and superimpose that with the PAUT data and actually use the encoder, the current encoder values. All right. So at the time, and still the case today, we are compatible with most nozzle scanner available on the market. You have here some from some competitors, but if you do develop your own scanner, you just need to make sure that your scanner is compatible with a quadrature or clock and direction, and you should be ready to go. Since the release of Capture 1.6, a lot of our customers have been using this application for the inspection of nozzles. You can find very thick nozzle like this one, which is a stainless, and it needs a special scanner with a clamp. This one here is a very thick nozzle as well. The thickness of the pipe was 120 millimeters, and you can see some defects inside, and smaller nozzles with customers inspecting them manually without the need of a scanner. In Capture 3.4, which was released 2 weeks ago, we decided to improve a little bit this application. So we introduced the ability to define a weld overlay on top of the nozzle component. So at the moment, it is only available for straight nozzle, so 90 degrees. But of course, in the future, we will improve that feature again. It is now possible to use 3-axis as well on a nozzle. Before, it was only on the main pipe and a 1-axis on the nozzle or node. Now you can also use 3-axis on the node or nozzle side. And we have made the TFM technique available for that component as well. So let's look a little bit of what we have right now. So in terms of weld overlay, those are the 3 type of welds that you can define. For a set-in nozzle, you can have a V-weld or K-weld, and you have here all the parameters that you have to input to define your weld. And then Capture is going to draw the weld 360 degrees on the component. And for set-on nozzles, you have a V-weld. So let's look at one example. So this is a nozzle we have at the lab. This is a carbon steel nozzle with a 400 millimeter main pipe and a 141 millimeter nozzle. And here is the weld prep. So you can see the heel, the gap, and the angle. And those are the parameters I entered in Capture, the corresponding parameters. The 2 left right here, the throat and the length, they are just here to help you define the weld cap. So, you just have to play a little bit with it, and then you get a feel on how to use it. So let's look at the interface. So here I'm in Capture. I'm connected to my Gecko through Wi-Fi using the dongle. You have here a sector scan superimposed on the overlay of the nozzle. So you have here the main pipe, the weld, and this is the nozzle. And you have the corresponding view on the 3D interface. And you can kind of see here in black, this is the same overlay as the one here in white. Now I'm going to turn along the rotation axis, and we are going to see what's going to happen. So as I turn, you can see here the probe moving on the 3D component, but you can also see the cross-section here changing in real time. So when you look at the PAUT data superimposed on the overlay, you will have a real position of your indications or back wall on the overlay of the component. So let's go until 90 degrees. We're going to move the probe until 90 degrees to have an idea. Right here, you go. And change our view right here. So you can see here that in black, the weld overlay on the 3D view, and in white, the same overlay. So you can see like Capture was able to calculate the weld around the nozzle, despite the complex nature of the component, and it's being displayed in real time using the encoder value right here. Now I can actually change, if I want, the index of set position, and you can see here that this is also changing in real time. We can see here the raise of the sectoral scan I have decided here. And something else we can do is we can change the third axis. The third axis on those scanners is the skew. It's the ability to kind of rotate the probe to be able to look at radial defects. So if I turn the probe here, you can see that instead of shooting directly at the nozzle, I'm kind of looking at an angle up. I'm going to continue right here. So I'm kind of shooting with the tangent of the nozzle to be looking for a radial crack. If I kind of turn right here, oops, problem with 3D, up. All right, here you go. So you can really see that I'm looking for a radial crack using the skew axis. So using the Gecko and the Mountless, since you have this 3-axis input, you can really benefit from any orientation of the probe along the component. All right, let's go back to the presentation. In terms of scan plan, with the application, you can use any linear arrays, matrix arrays, and if you are dealing with stainless, you can use DLA and DMAs. So you really have no limitation in terms of probes you can use. The probe can be positioned on the main pipe as before, or can be positioned on the nozzle or node, so no difference here. All delay laws are accessible, linear, sectorial, and compound scan. And if you look at the 3D view right here, you have a set of information that you can display. The index offset right here. The reference position for the component is the surface of the nozzle. The element numbers, the thickness of the components where the probe is positioned here on the main pipe or here on the nozzle. The refracted angles right here of my sectoral scan. My near field information. So in red, that means I am in a near field, so I can focus the energy. In blue, I am in the far field. And also the angle between the refracted angle and the bevel. At the moment, it's limited to the first leg, but of course, we'll add the second leg at a later time. In terms of trajectory, you can use a one-line scan or raster scan. So here you can see a one-line scan. So we're going to do simply a rotation for fixed index offset position. But sometimes, depending on the nozzle, the thickness, you might need several index offset position. So you can do a raster scan. Like you do a first rotation, increment, then you do a second rotation. You can also use that for corrosion mapping close to the weld. In terms, when you do the scan, capture is actually going to record the value of the 3 encoders. So even if you are only moving, when you are moving across the rotation, if you are moving the skew, capture is going to record that. So when you go into analysis later on, you will have a real cross-section for that particular position for which you change the skew or the translation. So let's go back to the sample we have at the lab. So in that sample, we put a lot of defects. So you can see here, we have a lack of pan, different cracks, center line, and so on. A transverse crack, which would be interesting to look at after, and a couple of lack of fusion along the V bevel here or the vertical bevel. So let's see, how the application performs. So for the acquisition, so here you will be seeing like the sectoral scan superimposed on the overlay, the 3D view, and this is just a cam of the actual inspection. So let's play. So you can see the probe moving along the primary pipe right here. You have the corresponding view on the 3D view. You can see that the overlay is changing in real time based on the position of my encoders right here. This is a C-scan, and this is a new feature of Capture 3.4. This is a scrolling C-scan. So this is just a zoom in of the scan, and as you scan, you have a zoom of the proper of this area. So you can see, like, during the acquisition, you already have this ability to see the overlay changing, the view on the 3D. So the operator is already getting a feel of if there is any indication. You can also actually do that without doing the acquisition. You can just move around and you will have your overlay as well changing. So if you want to do some kind of manual inspection in a way, but with the scanner, this is totally possible. You have access to all the standard views: C-scan, S-scan, E-scan, T-scan, D-scan, I mean, you name it. All the standard views that you have in Capture, you have them as well for this application. So let's look at the results and the data. All right, so now I'm actually looking at my PC, but it would be exactly the same on the Gecko or the Mantis. So we find again our sectoral scan here, 3D view, C-scan and A-scan. All right, let me zoom in a little bit and let me start right here. So this is the position for which the probe is aligned with the main pipe, and we can see a very clear indication right here, very strong indication on the A-scan, and it is positioned at the root of the weld. So this is where the overlay of the weld is very important. We can see that this strong echo right here is at the root. And if we go back and look at our sample, this is actually the lack of penetration right here. So let's continue scanning. I'm just gonna use the, so you can see like an echo right here. This is not a defect. This is the corner between my pipe and my nozzle. I can see it as well on the 3D view right here. So let's continue. Here you can see the crack in a heat affected zone. I can zoom on it up right here. I can even do some sizing. Let me get up here. I can put a second cursor up. I mean, I'll do that quickly. And I can see I have about 2.7 millimeters. If I go back here, in theory, my crack is 3 millimeters. So I went a little bit quickly, but just to show you that this is feasible. All right, so let's continue with our scan. So we have a strong back wall right here. Again, you see it in the 3D view. So here we have another echo in the center. And with Capture 3.4, if you want to zoom out, now you can actually double click here on the bars at the bottom. So that's another way of zooming out. So we can see here that we have an indication in the center of the weld. We have it as well on the second leg. So it would be like doing this. And this is our center line crack right here. And we can really see that this is well positioned in the application. Let's continue. So here we have another strong indication at the bottom. We have it on the second leg. We don't really have it on the first leg. This is due to the position of the probe and the high angles. This is our slag that we see right here. You see the slag. We're going to continue scanning. The next defect should be the transverse crack. So it should be kind of right here. But as we turn, it should be kind of around here, but we don't see anything. Well, and the reason is because we are shooting straight at the nozzle and the radial crack is like this. So there is really no way for us for that orientation of the probe to detect it. But we'll get back to that later. So let me continue scanning. And now we have a very strong indication right here on the second leg. Have it that as well on the 3D view. This would be the lack of fusion right here. So in the future, as I mentioned, we'll add the ability to fold the sectoral scan based on the position of the overlay. Like this is the case for all the other components in Capture. This is a little bit more complex here, so we'll add that later in a further feature. So that's our lack of sidewall fusion right here. Let's continue. Again, strong echo along the back wall. So here we have a big echo right here along this wall, and this is our lack of root fusion right here. And finally, looking at the other defect, the last one, up, we see a very strong defect along the back wall. This is another lack of sidewall fusion, the last defect right here. So really having this overlay really helps us reposition the defect properly and kind of understand what type of defect they are. All the features available for all the other components are still available. For example, here, I can display my gate and I can try to, because I see like a lot of strong echoes coming from the geometry, I can kind of adjust it a little bit, reprocess my C-scan, and here I see all my defects, 1, 2, 3, 4, 5, 6, 7. I'm missing the radial crack, but really quickly, I can see everything. As I mentioned before, we have also, this is the D-scan. This is small new feature of Capture. We have changed here the icon, and this is a ladder based on the view, S for S-scan, D for D-scan, and so on. But here on the D-scan, we can really see also the extent of the defect. Again, I'm going to zoom out, double-clicking right here. One of the features I can change, and I can see some of the defects appearing based on my angle on the D-scan. I said like all the features are available. So if I want to do some auto sizing, which is a feature that was released back with Capture 3.1. So here I didn't do a TCG, so I'm just going to do auto sizing based with a -6 dB drop. I'm selecting my icon right here, and automatically captures looking for the maximum of my indication, sizing along both directions of -6 dB. Let's do that again here. So this one is interesting. We can see that the defect is not really continuous. Maybe this is a lack of coupling. Maybe the defect is changing. So I know this is part of the same defect. So what I'm going to do is I'm going to select the second indication. So I have indication 2 and 3. And I can go into my table of indication. I can select my 2 indication and I can merge them. And you see now I have the 1 indication for that defect. And I can erase the 2 original one. My table of indication, as usual, I can customize it. I've done a nozzle one. So I can see here the scan start and scan end of each of my indications. I can take a snapshot and add it to indication number 2. If I zoom out again here, I can go back to indication number 1. I can take a screenshot, add it to indication number 1, and so on, and do my analysis as usual, like for this component. And then I can go into my report. Of course, I can change the logo and everything else. I have all the information about my component. And then I go back to the bottom, and I have my indications with all the information I have decided to put into the table of indication. And then I can export it as a PDF or Excel. All right. So we saw all the defects, all the circumferential defects, but we missed the radial defect. So if we look at capture, I say that we have on these scanners the ability to have a skew. I can actually, if you look here, I can actually tilt my probe right here. And if you look at the capture interface, this is exactly what I'm going to do. As I move my skew, the probe is going to tilt. I showed it before, and we can put the probe in a position for which we're going to be sensitive to radial crack. This is what I did right here. I tilted my probe, I changed the skew, and then after I can just do the scan the same way I've been doing the scan when my probe is looking directly at the nozzle. So here I'm just pushing it a little bit. All right. And you can kind of see the orientation of the probe. I'm kind of looking, I'm tangential with the nozzle, looking for radial cracks. So let's look at the scan right here. You can see that we have way less information because we are pretty much missing all the circumferential defect. And let me put a top view. You can kind of see here. And as I move my probe, you can really see that my probe is really looking, it's being tangential around the nozzle for at 360 degrees. And when I arrive here, I can see that I have a strong echo along the back wall right here. So let me reposition the probe. So I have my defect right here. So it's a radial defect coming from the nozzle. And if I look at my drawings right here, this is the crack number 5. So my probe is positioned this way and looking with the beam perpendicular to the defect. And you can really see here on the 3D view. So really, it's a good help for operators to understand how the probe is positioned and where the defect is located. So really here, you can really see where the defect is located. And finally, one of the features we also added for this component is the ability to use the TFM, total focusing method. And actually TFM now, we can use it for any component on the gecko. So before it was limited to pipe and plates. Now you can also use it for nozzles, fillet wells, and the true 2D CAD files that we have introduced in Capture 3.3. At the moment, it's limited to the direct modes, TT and LL. Of course, in the future, we will expand that to indirect modes like the 3T, 4T, and so on. You can use the TFM from a full matrix capture, but you can also use the plane wave imaging. So you can do a sectoral scan and then do a TFM afterward. And of course, this application is benefiting from all the new features in Capture 3.4, meaning that we have doubled the number of pixels that you can use. So now it's about 2 million pixels on the gecko and 900,000 pixels for the mantis. And we have also increased the speed of TFM between 10 and 30%, depending on the configuration. So let's look at the data. And you can see that the data looks very similar to PAUT here. If I go to my first defect, the echo seems to be a little bit more focused, of course, because I'm focusing everywhere. So this is my lack of penetration right here. I can see here my lack of sidewall fusion along the vertical bevel. Here, this is my lack of root fusion. But lack of sidewall fusion right here. So it should be here on the second band. So in the future, when we add the 40 mode, it should be positioned correctly right here. But still, you can pretty much get the feel of where it is. I just look at the symmetric right here. The slag right here. The crack right here. And finally, the crack in a heat affected zone. And again, I can just size it, click here, put a second cursor and do that. Kind of find my 3 millimeters again. So really, like, now you have access to every single technique on these components. And finally, the last feature we have added to it is the ability to use 3 axes from the nozzle side and the node side. So what I've showed you so far is doing inspection from the main pipe. But before, you were able to also do it from the nozzle side, but you are limited to 1 axis. Now you can really use the 3 axes, meaning you can have a rotation on the nozzle, you can move the probe along the nozzle or the node, and you have the skew as well. So if you have a proper scanner, I'm just showing you here a prototype from my colleagues at Silverwing, where you have the rotation using a links modification, a translation like here, and the skew. You can see the skew. So really, the operator can move the probe and following the weld and to be perpendicular to the weld at any time. So really, that helps operator perform a semi-automated inspection, recording the data, having a live cross-section view and making sure they are perpendicular to the weld. So they will help greatly accuracy and productivity and the POD as well. All right. So thank you for watching this coffee break. I hope like you enjoyed it. And now it's time for questions. So how do I get this application? So you just have to update your Gecko, your Mantis, or your PC version. This is available for all Geckos. And for the Mantis, I believe you need the Mantis TFM64. As soon as you upgrade your equipment, you will see the possibility of doing this. So if I go back to my Gecko, right here, I'm going to go back to the equipment. This is my component, my nozzle. And the weld feature is right here. You just have to click with. This is going to appear on your new version. And then you can click on modify. And you can choose set in V-weld, set in K, and set on V. So you just have to update your equipment. So please do it. And if you run into any troubles, don't hesitate to contact us. Can I use the application manually? Yes, you can. Of course, it is always better to have a scanner because you're going to have a real position in real time. But you can actually position your probe physically. So for example, here, if I go to the trajectory, I can decide, so I'm going to reset my cursors, and I can decide all the offset positions. So I can decide the scan position, the index position, or the orientation position. So I input the value, and I will have obviously a fixed cross-section, but that will help you then position your probe, and you can do a snapshot. So even if you don't have a scanner, you can still use the application, and that would help you position the indication. So what kind of scanner can I use? As I mentioned, there are a couple of commercial scanners available, and we are compatible with all of them. They are all in a library on our equipment. If I just go to here, equipment, and you go to the library right here, you have all the scanners available on the market for other applications, but you have those available as well for the nozzle application. But as I mentioned, you can develop your own scanner. As long as you have 2 or 3 axes and you use encoders compatible with the Gecko and the Mantis, so like a 5-ohm TTL, we'll make sure that your scanner is compatible for this application. And you can kind of see like a sneak peek of the node scanner developed by our colleagues at Silverwing, kind of uses the same principle. How does Capture handle matrix array for this application? So far, I've shown you like the application using a linear array, but I mentioned that you can also use a matrix array. So it could be actually interesting for this application. Let me load the file I've prepared. All right, so here, instead of using 32-element linear array, I'm going to use a 64-element matrix array. So it's going to be a 16 by 4. So let me go back to the equipment to show you. So here, if I click on the matrix, so I'm using this matrix array. I have 16 elements here and 4 elements this way. And if I go to my settings, for my delay lows, instead of looking at one plane, you can actually look at different planes. So what I'm doing right here is I'm going to scan in 2 different directions. So this way, maybe I can look at radial and circumferential at the same time. So let's look at what's happening when I go into inspection. So here, if I was doing this, I would be kind of looking for some weird orientation, but I can change my skew to make sure. Let me put a top view. It would be a little bit more interesting. So I can pre-position my probe. And you see here, I would have 2 directions. One plane would be looking for circumferential defect, and this plane would be looking for radial defect. And as I rotate, both, so here you have, actually, you would have 2 sector scan. Actually, I made a mistake. One of the sector plan would be at -20 degrees, and the other one would be at +20 degrees. So you can display the 2 sector planes at the same time. Here you go. And as I move, you would have the 2 different planes. So that would be another way of using the matrix arrays. I don't know if there is another question. No, I think we are okay. So yeah, if you have any questions, here is my email, freverdy@eddyfi.com. So don't hesitate to contact me or any of my colleagues, and we'll be more than happy to show you this application or any application in Capture. So again, thank you for watching this coffee break. I hope you enjoyed it, and see you next time.